So yesterday I was scrolling through YouTube and this thumbnail caught my eyes. Big bold text, building Devin in 4 hours. And my first thought honestly was, okay, clickbait. But fine, I clicked it anyway. Because I figured out, even if the title is exaggerated, at least there will be some real architecture discussion. Like, here is what Devin actually is. Here is how the agent loop works. Here is what the hard problems are. And here is how far we can get in a stream. That would be a genuinely good video. But that's not what it was. I watched the whole thing and I came away genuinely unsettled. Not at the person, but at what thousands of people in that audience now believe is possible. Because the framing was not here is how far can you get in 4 hours. The framing was this is Devin. We built in a day with vibe coding and Claude Code wrapper. And look, Cognition AI raised $175 million to build Devin. One of these things is not like the other. So I want to spend the next 15 to 20 minutes doing two things. First, I want to show you what Devin actually is under the hood. Because I don't think most people, including the person who made that video, actually knows. And second, I want to walk you through the specific technical decisions that were made in that stream and explain precisely why they don't add up to what was claimed. By the end of this, you will have a clear picture of what a real implementation looks like, what's genuinely hard, and how to spot when a tutorial is giving you a broken map. Let's get into it. What Devin actually is. Here's the first thing. You need to get clear in your head. Devin is not a model product. It's not GPT, but for code or Claude, but that can run in terminals. Devin is an infrastructure product that happens to have an LLM inside it. The LLM, however, is the least interesting part in it. Think about it this way: the LLM is the decision engine, but that decision engine needs an environment to observe, tools to act on that environment, a memory system to hold context across actions, and a recovery mechanism for when things go wrong. Devin has all four of these built out to production quality. That's what the money paid for. And that's what most autonomous agents have. What does the architecture actually look like from what's publicly known? There is a persistent sandbox container for each session. Inside that container, there is a terminal, a code editor, and a headless browser. There is an agent loop sitting above all of this that uses an LLM to decide what to do next. Read a file, read a command, click a button in the browser, or ask the human a question. And there is a memory system that keeps the agent coherent across what can be hours of continuous work. Now, here is the distinction I want you to burn into your brain. There is a difference between using a frontier model and building an agent system. Claude Code is itself an agent. It has its own tool definitions, its own loop logic, its own context management. If you call the Claude Code SDK and pass it prompts, you are not building an agent. You are building a client that passes tasks to Anthropic's agent. What you have built is a front end. The agent is Claude Code, the Google search analogy. If someone built a text input box connected to the Google Search API and called it a Google clone, you would immediately see the gap. The text input exists, surely. The actual product is the crawler, the index, the ranking algorithm, the infrastructure. None of that exists. That's the same gap we are dealing with here. The $175 million were not spent on API calls. It was spent on persistent sandbox environments that don't fall apart mid-session, reliable browser automation that can actually navigate real apps, multi-step task recovery. So when something breaks, the agent doesn't stop. Context management across tasks that can last hours and human in the loop escalation logic that knows when to ask and knows what to ask. That's the product. The LLM is just the part that reads and writes. So, what was actually built in that live stream? Okay, so let me be concrete about what happened in that live stream. And again, I'm not trying to be unkind, I'm doing a technical accounting. A markdown spec file was written at the start. Honestly, this part is good. Writing a spec before you build is legitimate engineering practice. Spec driven development is real and useful. The problem is that the spec had zero coverage of hard parts. No agent loop design, no error recovery strategy, no context management plan, no thought given to sandbox lifecycle. It was a feature list and a UI description. That's a product brief, not a system spec. Then Claude Code was invoked to generate a Next.js frontend and an Express backend with Postgres. And this works. Claude Code is genuinely impressive at this. But what's happening technically is that Claude Code is doing the work. The live stream is directing it. That is using an agent. It's not building one. The distinction matters enormously, and I will come back to it. Second point is E2B was chosen as the sandbox layer. This is a reasonable choice. E2B is a legit product for spinning up code execution sandboxes. But here's where the framing goes wrong. E2B is one component of the execution layer. Picking E2B is like picking Postgres as your database. You still have to build the rest of the application. Saying we solved the sandbox problem with E2B is like saying we solved data problem with Postgres. The database is there, nothing else is. The session ended with a partially working UI, no real agent loop, no memory system, no error recovery, and an OAuth problem that actually exposed a fundamental misunderstanding, which I want to get into right now. Section 3, the technical failures one by one. This section is going to be long, and I'm not going to apologize for that because this is where the actual learning lives. Confusing wrapping Claude Code with building an agent. When the Claude Code SDK was discovered in the stream, the confusion was we can just call this programmatically for each user, pass their task in, use their own API key, and that's the agent layer. And I understand why that's appealing. It's very clean shortcut, but it reflects a deep architectural misunderstanding. Cloud Code itself is a fully autonomous agent. It has its own tool definitions. It has its own loop logic. It manages its own context window. It makes its own decisions about when to read files, when to write files, when to ask humans, and when you wrap Cloud Code, you have zero control over any of that. And let me be specific about what you can't control. You can't control how the agent decides which files to read. You can't control how it manages its own context window. When the codebase gets large, you can't control how it recovers from tool call failures. You can't control when it decides to stop and ask the human a question versus just guessing. You have zero knobs. What that means in practice, your product's quality ceiling is exactly Cloud Code's quality ceiling. You can't improve it, you can't specialize it for your use case, you can't tune the error recovery. You are fully dependent on Anthropic's roadmap. If Cloud Code gets worse in a release, your product gets worse. If Cloud Code doesn't handle a certain type of task well, your product doesn't handle it either. A real agent implementation means writing your own tool definitions and your own loop. Concretely, that means a batch execution tool, a read file tool, a write file tool, a browser action tool, and critically, a request human input tool. And then you write the while loop that calls the LLM with that current context pulls out the tool calls it wants to make, executes that tool call in the sandbox, feeds that result back into the context, and decides whether to keep going, replan, or surface something to the human. That loop is where all the interesting decisions live. How does the agent detect it's looping? How does it distinguish between this test keeps failing because of the syntax error or this test keeps falling because of my approach is wrong? How does it know when a task is actually complete versus when it's just stopped? None of that is handled by wrapping an existing agent. That's all work you have to do. Failure 3, zero context engineering. This one is the quiet killer that doesn't show up in a 4-hour demo because 4 hours is not long enough to hit the wall. But in production, this is the wall. There was no discussion anywhere in the stream of how the agent manages its context window across a long task. No memory system, no file retrieval strategy, no session summarization, none of it. And this is not a detail. This is what separates a demo from a product. Here is the math, a real code base. Even a medium-sized startup code base can have hundreds of files, tens of thousands of lines of code. If your agent looks files naively into context as it works, it will exhaust 200 token context window in minutes on any non-trivial task. After that, the model starts hallucinating. It hallucinates file contents. It makes changes that conflict with changes from 3 steps ago. It loses track of what it has done. You will see it re-implement a function that already exists in the wrong place with the wrong signature. What a real context management system looks like. Two-tier memory. Ephemeral context holds the current task, the most recent tool calls, and the files actively in the scope. Persistent memory holds project level knowledge, architectural decisions, past session summaries, known constraints. The agent reads from persistent memory at the start of each subtask and writes to it at the end. On top of that, smart file retrieval. You never load a full file. You use grep style semantic search over the codebase to find the relevant sections. Load only those sections and summarize the rest. The agent never has a hold on all of 2000 line file in context, just the 40 lines that are relevant to what it's doing right now. And then there is the scratchpad pattern. A markdown file the agent mentions separate from conversation history, what it has tried, what worked, what failed, and what the current plan is. This is how you get coherent state across a 90-minute session. Without it, the agent slowly loses the thread. Testing this is actually straightforward. Run your agent on a 50,000 line of code base with a moderately complex task. Measure how many steps it in before it starts making decisions that contradict earlier decisions. If that number is low, like under 20 tool calls, you have a context problem. This is active engineering work. Failure 4. The multi-repo problem dismissed in one line. Someone in the chat raised this during the stream. What happens when the app has a separate front-end and back-end repository? The answer was basically add both repos to the project. That's a config thing. It's not. It's not a config thing. Multi-repo agent sessions are one of the genuinely hard unsolved problems in coding agents right now. The core issue is that the agent must maintain coherent understanding of cross-repo API contracts. If the front-end calls a backend endpoint with a certain payload and the agent modifies the backend to change the shape, the front-end breaks, and that agent has to know that, reason about it, and propagate the change. That requires the agent to have an explicit model of the dependency relationship between the two repos. There is also the problem of shared types that live in one repo but are consumed by another. Dependency version mismatches that only manifest when both repos are actually running together. Test failures in repo A that are caused by changes in repo B. The agent's context window problem multiplies across both the repos. These are not configuration problems. These are unsolved research problems that real agent systems are actively working on right now. Dismissing this as a UI config thing in a 4-hour live stream and calling it a Devin clone is, I don't know what to say. I want to be precise here, a misinterpretation of the state of the art. Section 4. Why this matters for learners. I want to keep this section short because I don't want to be preachy about it. Building in public is good. Attempting hard things on a live stream is good. Showing the messy process, the failed approaches, the wrong turns, that's actually the most valuable thing a technical creator can do. The problem is not what was built, the problem is the framing. 4 hours while coding Devin Claude, and you are not even covering the basics of it. Thousands of people now carry a mental model where building production grade agent systems is an afternoon project, achievable by anyone who knows how to prompt Claude. And when those people go and try to build the real thing, and some of them will, because that's what good learners do, they are going to hit the OAuth problem and the context problem and the agent loop problem, and they are going to think there is something wrong with them. They will conclude they are not smart enough. That's the damage, not the code, the map. The standard I try to hold myself to: if a learner watches this video and goes to build on top of it, do they succeed or do they fail? That's the question. So let me give you the correct map. What actually building this looks like. This is going to be a roadmap, not a tutorial. I want to be honest about difficulty. There are 4 layers, and I'm going to give you a real picture of each one. Layer 1: the execution environment. The sandbox is not the hard part, but it needs to be done right. Each session gets on an isolated container. That container is spun from a reproducible template. Here's the part that trips people up. The template creation pipeline has to read the repos package.json or requirements.txt or maybe Docker file and construct the right container for that specific project. That's non-trivial for arbitrary repos. You are essentially building a light version of a CI/CD provisioning system that works on arbitrary inputs. Honest estimate: getting the execution environment right for the general case, arbitrary tech stacks, arbitrary repo structure is weeks of engineering, not hours. Layer 2: the agent loop. Write your own agent. Do not wrap an existing agent. That loop has to receive the user task, break it into subtasks using a planning call, execute each subtask by observing the environment and making tool calls, maintain a running scratchpad, and implement a real error classifier. Cloud Code even has many sub-agents. You have to take care of that also. The error classifier is where most demos fall apart. The happy path is easy. Real code bases throw transient sandbox errors. Retry those with backoff. They throw logic errors, replan subtasks. They throw blockers. Something is ambiguous. File is missing. The agent genuinely doesn't know what to do. Those need to surface to the human with a specific useful question. Note: I encountered an error. The migration file references a column called maybe user ID, but the existing schema uses user ID without underscore. Which convention should I follow? That's what a useful escalation looks like. Getting the error classifier right is probably 3 to 4 weeks of real engineering on its own. You need to classify errors, and to classify errors well, you need to have seen a lot of them. Budget time for that. Maybe reinforcement learning is the key. Layer 3: context engineering. This is where the quality difference between a toy and a product lives. Implement the two-tier memory system, add semantic search over the code base using a lightweight embedding model. Doesn't need to be expensive, something like mini LM runs locally and is fast enough. Implement the scratchpad pattern. Summarize completed subtasks before they scroll out of the active context window. This is also the for the people who say red is dead, red is everywhere. Now validate this empirically. Run your agent on a large code base and measure when it starts losing coherent state. Keep iterating until it can hold coherent state for at least an hour of continuous work on a real code base. Layer 4: the human in the loop interface. This is directionally what the livestream got right, but technically got wrong. The user-facing interface should show a WebRTC stream of the browser inside the sandbox, not a URL. It should show a simplified activity feed, not raw tool calls. When the agent needs an input, it should ask in plain English with a constrained option, yes or no, or pick one, fill in the field. Never show code to the non-technical user. That's what they are paying you to handle. And this layer is the easy part. Build it last. Seriously. The agent doing good work matters infinitely more than the interface looking good. Build the core first. Three red flags to watch for in agent tutorials. The demo runs perfectly end to end with no failure. Real agent systems fail constantly. If you see perfect run, either the task was trivial simple, the failure were edited out, or the demo was scripted. The tutorial conflates using an AI tool with building an AI system. Using Claude Code is not building an agent. Using LangChain is not building a RAG system. If the tutorial's output depends on a third-party agent to do the actual work, the tutorial is about integration. That's fine. Integration is real, but call it what it is. The complexity. The complexity estimate is suspiciously low. If someone tells you a system with the architectural complexity of Devin can be built in an afternoon, the correct response is to ask what they are leaving out. Something is always being left out. Find it before you invest 6 months building on a broken foundation. Build the thing, but build it knowing what it actually is. That's the only way you get better. If this kind of technical deep dive is useful to you, the actual architecture, not the hype, subscribe. I'm going to keep making these, and if you want to start actually building real agent systems, I've got a series on RAG and agent loop implementation linked below. Start there.